Yeah, yeah. So I'm about to start. Yeah. Wow, too hot. Hey, hello, ROS developers. Welcome to the new ROS developers live class after we have done the ROS developers conference, actually. So if you remember, we interrupted for a couple of weeks the creation of these live classes so we can dedicate some time to properly prepare the ROS Developers Conference. I don't know, some of you already were during the conference, some of you attending to the live class, and I'm super happy to see you there. In case that you didn't, please check our channel because we are posting the conference videos and then you can watch them and learn a lot from all the speakers. Okay, so let me see if the people is ready on the chat today, because today we are going to learn about how to program robots with C++. Well, actually, it's a very basic class, introduction to C++ applied to robotics by using ROS. I mean, so you don't need to know anything about C++, you don't need to know anything about ROS. Okay, it's very introductive class. So let's go and let's see who is there. I can see here Diraj. Hello, Diraj. He's ready. And then Junjuan, of course, as always. Hello, Junjuan in China. Marcus, hello. Adam also. Leon Lobos, hello. So first time see you here, I think, Leon. And well, I see that there is more people there. Remember, you can use the chat that is beside this video in order to ask questions during the live class. So how we are going to proceed today is as follows. First, I'm going to share with you a project. Then this project contains all the notebooks with instructions, with information about C++ for robotics. And then we are going to open, all of you, you and I, at the same time, we are going to open this project. Each one of you is going to open his own project, of course. There will be no interference. And then you are going to follow the instructions I will be saying and showing on the screen. So you are going to practice with me at the same time. So that's amazing, isn't it? And for that, you don't need anything. You don't need to install anything in your computer. You don't need a special computer. You just need a web browser. Do you have a web browser in your computer? I beg that, yes, that is true, that you have a web browser in your computer. Anything, Linux, Mac, Windows, whatever. Anything that has a web browser. So let's start. I see that more people is coming. Denisa, hello. Jacob, Der Capute, and Jan Mate, hello, hola, everyone. And the number of people increasing here attending the live class. You all are welcome. Remember, let's get the project right now. If you have questions, use the chat. Let's go. So first, I'm going to share with you my screen so you can see what I am doing with the ROS Development Studio. And here, well, I have already opened because I was preparing for the live class, but let me go to my list of projects inside the ROS Development Studio. And here it is, the one that we are going to use today. And I'm going to share that with you so you can get a copy. So this is a copy, and then I'm going to post this link into the chat. So you can copy my project. You can get a copy of my project by clicking on that link. So go to the chat and click on that link, and then you will get a copy of that project. Everything will be copied automatically to your zone inside the ROS Development Studio. And remember that you only need a free account in order to execute all this. Oh, I see that Sohin is here. That's all right. Hey, Sohin, that's a pleasure to have you here today. So how is ROS agriculture going? Berkay, hello, just arrived. Okay, Berkar, go and click on that link to get a copy of the project. So when you click on the link that I have posted, you will get a copy of this area here. You know, you see? So maybe you don't have an account at the ROS Development Studio. Don't worry, just create it. The system will guide you into how to get this, first creating an account, and then you will get the copy of the project. And then once you have that, click on more. And then on more, click on Open ROS yet. You have several information here. You can share, you can copy, add comments, issues, etc. So click on Open ROS yet, and then the ROS yet will open. It's as simple as this. And then you will get automatically, let me close the previous tab. Yes. So automatically you will get a copy, or it will open directly the notebook with all the instructions. So you are going to be guided from the very beginning. In any case, I'm going to be here, so you can ask me things in case that you get lost, okay? So let's open the ROS yet. Let me salute the people on the chat. Daniel Badranapu, hello. All the newcomers, you can come and get the ROS yet by clicking on that link, okay? Go for it. In the meantime, that my ROS yet is opening, and Shohin is saying, oh, doing well. I shared info about this class. Hopefully more will be joining. I missed the Python class. Glad I could come to this one. Okay, great. Thank you, Shohin, for sharing the class. Yes, I can see that many people is arriving right now. And then about the Python class, you can go and check the video on the that it's already published on our channel. Let me see what is happening here. Why don't we have this already open? Should already open. Let me refresh and let's see. Okay, so it's taking too long. Shouldn't take so long, but let's wait until it recovers or does something. Let's see. So in the meantime, you can ask me any question if you are confused there. Don't worry. So here I have a question from Song Dao Mi. He says, hello, anybody in here know about Cartesian? How to add Cartesian plugin in RBase? Thank you so much. I don't know which plugin are you talking about. Cartesian plugin, what is that for? And Daniel Badranapu says, I've seen your navigation stack tutorials. They are nice. Thank you very much, Daniel. Let me see. Oh, that's very strange that it's taking so long. Actually, I had already opened, and then I don't know what could be happening here. It looks like everything is correct. Yes, it's connecting, trying to connect to the remote services. And for some reason, it's not getting. Let me check my Wi-Fi if it is correct. Yes, because I'm transmitting properly. Let me know if that opens for you. If it opens, so if you have any problem. And Benjamin says, yeah, hi everyone, hola desde México. Hola Benjamín, ¿qué tal? Actually, my brother is called Benjamin, yes. So nice to see you, Benjamin. And also, Yunus Emre, I don't have Wi-Fi, but I'm watching you. Yeah, so how can you see this if you don't have a Wi-Fi? Dirash says, hey, I want to ask if this simulation is really available for educational purposes. Yes, so it's not a simulation, it's a development environment, the complete development environment, and you can use it for educational purposes. There are some free accounts with a lot of hours there. After refresh, it's working. Yes, it's in refreshing, but it's not working for me. I don't know why it's happening this. So let me go back to the project list and then go back and open it again. So let me check. So we have some logs also. I will check then. Leon Lobos just opened. And then also Sondao says Cartesian Path Planner plugin for Moveit, sir. Ah, okay. So yeah, okay. Woof, that's very complicated. That's a lot of work here. So maybe what we can do is to prepare a live class related to that subject, specifically, Sondao. Then Benjamin says, so mine is open. Can you also suggest some good material for learning C++? And yes, about good material for learning C++. Yes, there is a nice course here that says it's, let me check it here. Let me put it here. So I don't know what is happening here. Let me just close it and see. Let me open another one, for example, this one. And in the meantime, I'm going to check. So it's called, let me think, it's called Learn C++. But it's, let me check if this one. There's one specific one. It's not that one. Well, that one is okay. That one is okay. So it's learncpp.com, but that's not the one that I was looking for. It's this one. Yeah. Yes. I think that this one is quite interesting. It's a basic course, but it's very good for introduction. So this one, learncpp.org. Let me write it down on the here. It's here. And Sohin has shared some material. Great, Sohin, thank you. Danny Das has arrived, yes. And it looks like I'm suffering some problem here. I don't understand this. Okay, it's open already, but I mean, that's just stupid. That's not how it is supposed to work. So let me go back and open again my project, my ROS for today, because I opened another one. So let me open. Let's see if that's working. Fortunately, yeah, so that's how it has to work, like this. Just I change the rosette and then it opens, but very quickly. But I don't know what happened there. I don't know. We'll check the logs afterwards. So my friend Marco Arruda, who is one of the main developers of the ROS Development Studio, he has included many log systems, so we can check afterwards what happened and figure out. Okay, let's go, because we have lost a lot of time. Now you should be, all of you, opening on this screen, okay? So in case that you don't, for whatever the reason, don't worry. You have closed the notebook or you selected another option. Don't worry. How can you get that back? It's very easy. Go to Tools, select Jupyter Notebook, and then it's going to show you all the notebooks that have been included into this ROSjet, CPP, C++ for robotics. And that's the only one here. Okay, there is only one. You click on there, and then it's going to open automatically. And then that's it. That's it. You got it. Okay, so you know now how to get back to this. So what are we going to learn here? Very, very basics about C++. Okay, very basic concepts. We don't have more time, yes, but that's an introduction, and we are going to apply as much as possible to control a robot, as much as possible. Okay, I don't like to teach language per the language itself. I want to teach because I want to apply to something useful. In that case, it's for robot control. So that's what we are going to follow here. And that's exactly the same procedure that we follow on the previous live class, the one about Python for robotics. So let's go. We are going to learn how to create and execute a C++ program for robot control. And when I mention robot control, I mean within the ROS framework. Okay, so it's a little bit different from creating C++ programs for general purpose, for general applications. So that's a little bit different, a little bit, okay? So we are going to see the proper procedure for how to create and execute a C++ program for robot control under the ROS framework. Then we are going to create a function and use it to get data from a robot sensor. So you will learn what is a function and how to create it. And also, we are going to create a class to move a robot. So we are going to, a class, I mean a C++ class, okay? And why this class? I mean this live class, okay? So it's different, live class and C++ class. That's something different. I suppose that you understand the difference. If not the case, if you are getting confused, then let me know, because that means that the level of programming here, then it's a certain level, and then I need to explain you, okay, if you don't understand what is a class. But I'm going to explain you anyway below. So what do you need? What do you need in order to do this class? You need to want the aim to become a ROS developer, okay? As I'm showing you in my t-shirt, let me see my t-shirt. So many things here. So here in my t-shirt, you can see that I am a ROS developer. So you must want to be one in order to follow this class, okay? Yeah, so after this stupid thing, then let me share again this the screen. Let me see. And let's continue. Okay, so this here, it contains some information about how to use the ROS jet and explains how you can create your own ROS jets. Check it out for yourself. Okay, so what are we going to do today is to use this robot. It's called the Robotics MPO 700, and we are going to use, of course, the simulation for this. And how can we launch the simulation? By doing the following steps that we have here. First, we have to launch an environment, I mean a space in which this robot will be working. For that, go to Simulations here, menu, click there, and then select the ClearPath Playpen. This is an environment created by ClearPath. That's why we have called ClearPath. Okay, so we have borrowed this environment from the repo of ClearPath. That is an open repo, I mean, so you can take it, but we want to provide credit to the people who has created it. Then once this is going to launch, it's going to launch the environment. I mean, only the space in which the robot is going to work. And then after a few seconds, then we'll get here the environment. Then we are going to select the robot that we want to spawn into this environment. So we want to work on the ClearPath with Robotics. So it's loading here. And yeah, it's loading. Yeah, there it is. And let me check if there is any question. Says Leon Lobo says your screen is a blur, cannot read your development screen blurry, check camera focus. Okay, so it's not possible. That is a problem in the camera because there is no camera pointing to the screen. It's the screen itself that is being projected. So if it shows blurry, then there are only two options. Yeah, so probably as RZ is answering you, it's very likely that you haven't selected the proper configuration for the quality on the streaming. Okay, other people is reporting that the screen is clear, so it looks like it's a problem on your side. Maybe your speed connection is very low, so YouTube doesn't allow you to get the complete the quality that we are transmitting, or maybe you haven't selected. You are allowed, but you haven't selected. Follow the steps that RZ said. Okay, we have here the environment. Now let's launch the robot. Let's spawn the robot here in this environment. How do we do that? Go to Simulations, and then now you can see that the menu has changed in order to show the list of available robots that you can launch. And let's select this one, Robotics MPO 700. Select that, and then the robot is going to be spawned here some point in time. Should appear there. And then we can start creating a C++ program. Okay, so the robot, in my case, has been spawned already, is there. Okay, so there it is, the robot. Yes. Okay. So far, so good. Then let's go and let's create the first program. So for that, we need to use the IDE. We are going to use the integrated development environment that is included here in the ROS Development Studio. And for that, let's go to Tools and select IDE. Here it is, IDE. And here we have all the workspaces that we have. Then I have created already a package, a ROS package inside the Catkin workspace. What does it mean? So it means that in order to compile, to create and compile and execute a CPP program, you need to have a preset environment, especially in ROS, okay? In ROS. So in ROS, you need a Catkin workspace, and then you need to create a package. So this is not the subject of this live class. That's why I have already provided to you the Catkin workspace that is here, Catkin workspace. You can click on the arrow and open it, then go to source, open it, and then you can see here that there is a package called my CPP package. That is the one that I have created. And then it has two directories, the include one and the source. Okay, so we are going to create our program inside this source, the second source, okay? Not this one, but this one. It means it's the source within my CPP package. Then here you can do a right click and say new file. Then this new file has to be called, as I mentioned here, otherwise compilation is not going to work, okay? So just name it as it's indicated here on the notebook. How it is, it's called my_cpp_program.cpp. Okay, so as you can see, it has appeared here beneath the source. Okay, we have the file. This is the file that is going to contain our CPP program. And in order to work with ROS, it has to be included here inside the source, inside the src directory of the package. Okay, so how to build this and how to build that Catkin workspace, that's the subject of other live classes that we have done, so you can check, or any of our online courses that explain this step by step. Then, now we concentrate on creating a C++ program. And the first thing that we are going to do is to include this line that you can see here on the notebook. Just copy and paste this here as the first line. What does this line mean? This line means this is the way that C++ has to allow you to include other libraries. So imagine that you want to use other programs, other code that somebody else has created, some other company, some other researcher, some other person. Then in that case, you must use this keyword, include, and then know the path where these libraries have been installed. So this is something that you must know from the library that you want to use. In this case, we are going to use the ROS library. That is why we are including this. So this is the way to include ROS into our program. And if for any other library, you only have to change the content here in the inside of the brackets. Great. So now let's create our main function. The main function can be seen here. You can copy and paste here. And this is the function that indicates the program that is contained in this file is starting here. So from this bracket here, let me see here, from this bracket, let me put it here. I do prefer to put it there. Yeah. So then from this bracket beneath, then here is where my program is going to be. And all the program has to be contained between brackets. So you can close the bracket. Oh, sorry, I pressed a different button, sorry. So here, so you can press, close the brackets. Let me increase the size of the spaces. No, let me see where was it, the size, not here. The size of the, I try to increase the size of the, no, but it's not here. I don't know where is it. Okay, so I promise to check for the next one in order to increase the size of the letters here so you can see better. But I hope that you can follow me. Let me know if it is not the case. Then in between those brackets is where we are going to put our code, okay, for the program. Okay, so what is the code that we are going to do? Those two lines are first. So you can copy and paste here also. In this case, maybe you remember about the indentation, but in Python, that was very, very important. Then in C++, indentation doesn't matter. It doesn't matter. It's better if you use indentation, proper indentation, in order to get a clean code that you can follow, and also many other people can follow easier. Then in those lines, I have indented in order to indicate that is within, all this code is within this, but this is not mandatory, okay? I repeat, this is just for for making the code more clean and more understandable. So what do we have here is first, we initialize the options for ROS, for indicating that this code here is going to be a node of ROS. That's the configuration of the node. And then here we get the node handle. The node handle is the one that actually is starting the ROS node within this program. So it is all those two lines, they are indicating to the ROS master that this program that is being executed right now, it's another ROS node that is available for the ROS ecosystem that is running on the robot. Okay, so now let's add another line, is this one here. It's just a very basic print command in C++. And it's just going to print on the screen this message, that's all. And then finally, we can copy the return, but don't copy the close bracket because we already have put it there. Okay, so that's it. Then it says return 0. That means, hey, this program is finishing properly. That's why I return a 0, the last sentence of the main. Okay, so that is our program. How it should look completely, you can see it here. Now let's go and let's compile this. Well, remember to save this, okay? When there is a ball there, then it means that there are some changes that need to be saved. So you can go to File and then Save, or Control S also. And it automatically formatted the code for me. Okay, yes, whatever. Anyway, so we have that. And now we need to compile it in order to be able to execute. That's the difference between C++ and Python. In Python, you don't need to compile the code because as you execute it, then it is being compiled at the same time. In C++, that's different. You must compile the code. Compiling means generating the actual code that the machine, the computer of the robot, can execute. Remember that those instructions here are only instructions for us, for humans. So we can read and understand what is the code, but the computer doesn't understand this. Then it only understands ones and zeros. So there is a program that is called the compiler that is going to change all this into ones and zeros. That's the process of compiling. Okay, so that's what we are going to do. How do we do that? Well, in ROS, again, remember that we are talking in ROS. In ROS, there is a CMake List file here that you should have. That, let me close this source. So inside the myCPP package, we have a CMake List.txt. This is the file that is used by the compiler in order to understand how to compile that file. Okay, so that's the main file that helps us to compile everything on ROS, every program that we create here for ROS. So here we have to indicate in the CMake List, if you open it, then we have to indicate what to do. And for that case, you need to go, let's go down. Let me tell you the number of the line where you have to go. And it is here where it says bill. Where it says bill, then we have to actually remove some of those comments. As you can see here, we have some comments in the lines that you have to change and then allow to, that they will allow us to compile the program. And the one that you have to do is this one, is the one from the add executable, also the add dependencies here, and also the target link libraries. But also inside there, you have to configure properly with the name of your file. So you should remove the comments for those and then configure with the proper values. The proper values are already included here. into this cell that we have here. So it is better if you just leave those comments there and then copy and paste this. Copy, and then you can paste it, for example, here before getting into the install section. And basically, it's the same thing. I mean, it's the same thing that you have here instead of commenting here, but it's just more work, okay? Because we need to change here the name of the node that is going to be generated, the name of the CPP file, and the same applies in all the others that we have to comment. So as you can see, it follows the same structure, but with the proper values for the CPP program that we are going to compile. That's why we are copy and pasting. So please check afterwards if that makes sense to you. If you don't understand, let me know. Then remember to save, because it's the ball there. You can press Ctrl S, and then once we have this saved, then this is ready to understand. The CMake is ready to understand the compilation. How do we compile? How do we compile a program? We have to invoke, we have to call the compiler with the options that are included in the CMake list. And how do we do that in ROS, in the ROS framework? We do it by issuing this command, cat-make. Okay, so let's go and let's issue that. How do we do that? First, we need to open a shell. So let's go to Tools, open a shell. And then in order to compile a ROS program, we have to go to a very specific directory. Okay, so you cannot execute that command anywhere. No, it's not going to work. We have to go inside the Catkin workspace. So get inside the Catkin workspace here. And then remember that inside the Catkin workspace is where there is here is the Catkin workspace. Then we have the source, and then we have our package here. Yes, so it's here on the Catkin workspace, Catkin_WS, that we are going to issue that cat-make command. So you can type it and start compiling. Okay, so that's it. Remember, that's very important. That's a very typical error. People issuing the cat-make in another directory, and then it's not going to work, of course. So by doing this, we are compiling our program, and it's going to be ready for execution. I mean, it's a very simple program, I know, but let's build on that, okay? So now we are just going step by step, starting from a very low level of knowledge. Let me check if there is any question on the chat. Then says, Sied, hello, first time here, Sied. Nice to see you, Sied. Please go up on the chat and click on the ROSjet that is on top in order to get the copy of the material that I'm showing on the screen. So you can get all this material. It's called the rosjet.io. Click on that link. Then there is Shan. Hello from Singapore. Hello, Shan. Nice to meet you. Anihila Tionify. You are late. Yes, you are late. So you heard about CEST, so do the same. Then Benjamin says, so the CPP show me a yellow bar down the ID. I cannot access the CMake. Oh, that doesn't make sense. And that doesn't make sense. Let me see. What do you mean? The CPP show me a yellow bar. The CPP, what does it mean? The CPP show me a yellow bar down the IDE. You mean the file, or this? Your question usually means that you are not putting the CPP where it has to be. Then Kashif says, which CPP compiler version does this CMake use to compile the code? And that's a very good question. We should use the C+11. I don't think that we have activated that, because there is a line here for C+11 is this one, and then it's using the previous one that I don't remember which one it is. So it's the previous one to this one, but you can compile because Kinetic already supports. We are working on ROS Kinetic, as you can see here, so already supports C+11. So by if you want to compile using the C++11, you can do it by just removing this hashtag, there, and then it will compile. And now, because we are not, then we didn't, then it is compiling with the previous one. I don't remember which version it is. Colin, hello. Kashif says, I mean to say, what if I try to use some headers or functions using C++ STL? Can we compile it, or we need to add something in the CMake file? No, that's okay. They are going to be taken, and then you can compile them directly. The STL, of course, you don't need to do anything. Then Benjamin, it seems an error in saving. Okay, I don't know. An error in saving. Okay, so are you putting there, but are you sure that you are getting an error? Because, I mean, I'm getting a lot of red dots here, but I don't care about that. I know that this is correct. So you don't have to care about many things unless it's preventing you from doing whatever it is. Because this is, I don't know what is this red dot yet. This is something that we have activated in the system in a few weeks ago, and I still haven't had the time to figure out how to remove that. I think it's more related to the style of programming or something like that. I don't know. But in your case, you mentioned, so the bar you have in blue when you try to resize the text is yellow for me. It shows me that the ROS header is not found and that the ROS identifier is not declared, so I cannot move on to edit the CMake list. No, you should be able to open the CMake list. Probably you are looking for something different. Are you inside the Catkin workspace, source, my CPP package, then source, inside this source, okay, so sorry, inside this package, my CPP package, then open that one, this one. You should be able to open this. This is nothing to do. You mentioned this blue line here that is yellow in your case. So can you see the CMake list and then my CPP package? So that would be the first question. Colin says, words on a screen are not readable. Please enlarge the world if possible. Then yes, please, Colin, try to increase the quality of the please try to increase the quality of the stream. So if you go to the YouTube, you can increase instead of setting the quality automatic, set 720p in order to get better. But I will try to make it bigger also. I don't know how to do it here because no. There was an option here, but it's not there anymore. So I don't know. Settings, maybe here. I don't know. I'm going to waste a lot of time on that. So I'm going to skip that one. So now we have, let me continue with the problem. So we have compile the program, and now we are going to execute. How do we execute? Well, in order to execute, we have to go to the terminal where we have compile, and then we have just to launch the program. How do we launch a program in Linux? We put / and then the name of the binary that has been generated. But what is the name of the binary? It's indicated here in the CMake list and the lines that we have added here on the build. So the name is this one, the one indicated by this keyword, target link libraries, my CPP program. So that's the name of our binary that we should execute. And if I go to the terminal here, I should write, as it's indicated here, my CPP program, but it's not going to work. Why? Because, yeah, the file is not here. It's not being included here. So here in the Catkin workspace, I don't have the result of the compilation. The result of the compilation is indicated here. You can see here that is there. So let's go to that directory. You can go in this way, okay? Going into the directory, devel, then lib, then my CPP package, and then here inside is included the binary. So how do we launch the program? By doing // and the name of the binary, my CPP program. And then we got the result that is basically just printing on the screen, keep pushing your ROS learning. That is all for this program. Okay, so what do we have now? So we have created the basic C++ program, we have compiled it, and we have executed. Okay, I know that I have taken a lot of knowledge already for granted, that is the about using the ROS environment, but I imagine that you are a beginner. So in that case, you will start with that environment already there. So let's go and let's understand what is a function in C++. Now we have understood the basic behavior of a C++ program. That is how to create a C++ file, then how to compile it, and then how to execute it. Now let's include into a function, into the program, a function. Let's create a function. And what is a function? Well, a function is just a reusable code that you would like to call, to execute from different places. So imagine that you have a code that wants to be called from different places. Instead of copy pasting that code, you can create a function and then you just call that function at some point in time. So let's add a function here, like the one that we have here on the notebook. Let's add it to our program, and then let's see how it worked. Okay, so I will show you, I will explain you every part. So you can copy this structure that you have here in this cell, come here to the program, and then get beneath the include some place here just before the main. So you have to include it before the main, okay? Because we are going to call the function from within the main. So paste it there, the code of the function, and that's it. So let me explain what I mean by this. This is a function, and then the first thing that we have in the function, this is the definition of the function. And between these brackets, this bracket here and this bracket here, this is the code of the function. And remember that here the indentation doesn't pay any intentions. It's just for clarity and looking good and easier to read. Then what do we have here? First thing is this std string. This is the name of a class. This is the name of the type of data. This is the type of data that this function is going to return. So whenever we call a function, we can make the function to perform something and then give us some returning value. Then in that case, if that is the case, you should include here the type of data that the function is going to return. In this case, it's going to return a string. That means a set of characters. So that is why we are using std string here. Then we have the name of the function. So how are we going to call the function? By its name. Then that is the name. This could be whatever it is. For the types, you need to know the types defined in C++ or in any other included library. But for the function name, you can put whatever you want. You can put your name if you want. Or, I don't know, 2019 is the best year. That could be the name of a function. Okay, then you have to open brackets, and then in case that the function accepts parameters, you should put them here inside the brackets. So how do you specify the parameters? You can specify as many parameters as you want, as far as they are separated by a comma. And the procedure is very similar to what I have indicated here. First, you indicate the type of the parameter. I mean, is that a string? Is that a double? Is that an integer? So you specify first the type of the parameter, and then you specify the name of the parameter. That's it. If you have, for example, an integer there, oh, sorry, I deleted there. Then if you have an integer, then you can say an int, and then my age. I don't know, my age. and then go on and include as many parameters as you want. In that case, we have a parameter that is last name, and we are going to return another parameter that is a string. In order to return a string, then the last sentence of the function has to be the parameter to return. Okay, and this is a variable that we have been creating here along the code. So that is first, we have created this string, the string result. Damn it. So this string result is created here, is defined here with a basic value, and then it's well, yes. So basically that's it. So there is where we are setting, we are setting the value of the string result, and then we are returning the value of the string result to the place where this function is being called. Okay, so now we have included this function, but nobody is calling the function. So in order to call it, we need to go here in our main and then include a call to that function. So let's do it manually. I don't know if I remember having put, yeah, so here it is, how we call the function, yeah. So my last name, yeah. Okay, so this is the line that we can copy, and you can put this here, for example, after the line of keep pushing your ROS learning into our code. Then that, what does it mean? So that means that we are creating a string that is called result2. And then inside this new result2 string, this new variable, we are going to put the result of the printer function. So we are calling the function, and we are providing my last name parameter. So for example, I'm going to include here, instead my last name, I'm going to put Teles, that is my last name. So what is going to happen is that at this point in time, the program is going to call the function, and then it's going to call with this parameter, Teles. Then the code here is going to be executed, and the result is going to be returned, and it's going to be included into this result2 variable. It's result2 variable. Then we need to do something with this result variable. For example, let's print it out. So for that, std, you can copy it's there, the sentence, and type in directly. So result2. So by doing this, I'm going to print on the screen the result of the printer function. Okay, so let's do it. Let's save it. Let's compile again, and let's execute again. So for compiling, remember, so I have saved it. Compiling, remember, you have to go to the Catkin workspace now, and now here type your Catkin make command in order to compile the new version of the program. Let me check in the meantime if there are many questions. Wow, many questions there. So, so Benjamin is still with the problem. You have identified them, but I cannot access them. And then let me see, Benjamin. Sorry, Benjamin, I lost you there. It's very strange. What I would recommend you, Benjamin, is that you close the project, close it. I mean, go to this tab. Let me show you. Benjamin, go to this tab, go to this icon here of the wall, click on it, then a new tab is going to open, and then click again here on more, and open ROSjet, because the error that you mentioned makes no sense to me. If you do that, then all your changes, whatever you have done, is not going to be saved. So you can start from scratch again, unless you have pressed the icon of the saving, okay? If you press the saving icon, then it's already modified, but I hope that it's not like this. So then Yes, so click on the link on here on the icon, press on more, and then open the ROSjet and see. Let's see if that solves your problem. Then here we have a problem, a string copy, because it says that string copy is not being declared. Yeah, string copy, we do not have to use a string copy here because it's already done. So I don't understand why we do have here, oh, result has been not defined. So this is an error on my side here. So you can remove this line that says a string copy. Remove it completely, then save it again, and then let's start again, CMake. Hey, Benjamin, let me know if you tried that. Then let's see, Benjamin, then Kashif says, can you show us today about how to use our own header file? Like for PID class, I could make a PID in ROS CPP code, like here, where to save the header file in order to use in ROS CPP code. Yeah, that's very simple. So in case that you have your own include file, your .h file, you have to include here inside this directory here that you have. It's been automatically created by the package system. When you create a new package, a new ROS package, this is already provided. So you put your .h here, and that's it. Then you can include your own by using like this. For example, include, in that case, that would be my CPP package / PID, for example, H. That's it. And then then it will be compiled and everything. So you have to include it also in the CMake list also. Yes, you have to include it into here. Oh, no, yeah, but well, you only need to, no, it's already included. Yeah, it's already uncommented. So by default, that include directory is already there. So you only need to compile, that's it. Put your .h in this directory, and that's all. And then include it here in the main, in the CPP file. Okay, so now after that change, we have the code that is running, compiling, and now we have to execute. We should go again inside the directory, but instead of going up and then down, I do prefer to do like this. So put /, and then get into the directory that is devel, then lib, then the name of my package, and then the name of my binary. That's it. That's the same thing as if I went with CD until the directory. Okay, so here it says, what is your name? Then Rick Tellez, keep pushing your ROS learning. Yeah, so that's it, because it has been concatenating. Keep pushing your ROS learning with my name that has been asked here, and then with the last name parameter that I have provided. And then it has printed in this line everything together. So I hope that this makes sense for you in the case of the function, of creating a function. So now let's do a simple example with the robot, and we are going to finish here because too many things and too many questions. So we don't have time to watch the classes, but anyway, you have the code here and the explanation about how to do it. So you will have to do it yourself, and then ask me questions through email in case that you want. Then for the robot, what we are going to do is to create a function that is getting the lasers from the robot. So let's create another file here in the source. Go to the source here and then create a new file with a right-click, new file. And we are going to call it, let me see, I want to use the same names in order to compile easier. Then obstacle in front .cpp. So you have created this one here. Now let's copy the code very quickly here. It's the code that you can put here. And what it's doing, this code, is several things. First, it's including another library of messages from ROS. is about the laser. So we can interpret the laser data. Then, as you can see here, you can identify that there is the main, that's, as you already know, the ROS init, the node handler, and then we have a couple more ROS functions that you don't know, but you don't need to know. The only thing that you need to know is, well, this is creating a variable that is called sub. So this is the name of the variable, and this is the type of the variable. It's a ROS subscriber. And what does it do as a ROS subscriber is to read the data from a topic. You don't need to know what is a subscriber or a topic. Just understand that this line here, what it's doing is reading from a laser, and whenever this laser generates some data, then it's going to call the function that you specify here. Okay, so this is the name of the function that is going to be executed. This one. And the function has been defined here. You see, this is the function. And you can see that this function has void at the beginning. Instead of CPP here that it has std string, in this case we have void. That means that this function is going to return nothing. So void, when you don't want to return anything, then you put void. That is why there is no return sentence here. As you in comparison with our previous program that we have this return, and we also had this std string. Yes. Then this is receiving a parameter. Here is a reference to a pointer of a laser scan, whatever the type it is. So this is a complex type, not necessary to understand right now. It's a complex type, but basically it receives a scan of data from the laser data that has been generated by the laser, and then it's getting the ray of the laser that is just in the middle of the robot, just that ray. And then it's going to show us what is the range. It's going to show on the screen what is the range, what is the distance detected by that ray. So basically that's it. As you can see here, we have a function. That's the purpose of this example, to show you how to use a function for getting data from a sensor of a robot. Okay, so let's compile it. Then remember to save this file. Then we have to modify again the CMake list. Go to CMake list and go to the end of the build. You see, do you remember these lines? Then we have to add 3 more. So those 3 more are indicating that we have to compile this new file that we have generated, and we have to generate a new different program that is called obstacle in front. So copy these lines and add them here in the beneath the other 3 lines from the previous program. So you can see how the structure is. You can see here we have another program, and you can see what is the difference between this one, and then you can make in your head, you can understand better how to create this for your own programs. Okay, remember to save this, and then let's go again here and do a cat make. So now it's going to compile the second code, because the previous one was already compiled. This CMake list is indicating that both have to be compiled, because we have those 3 lines for both programs. But since this one has been already compiled and nobody has modified, then this is going to not to be compiled. But the one that is going to be compiled is the new file that we have here. And we got it, and says build target obstacle in front, and let's execute it. So how do we do? In the same way as we did previously, devel lib my CPP package, but now instead of my CPP program, we are going to call obstacle in front. Okay, so let me put it bigger, larger, this. Okay, then it says 1.8 is the distance. So if we move the robot at some other place, so I can select the robot and then use these keys here in order to move it. For example, here. Then in order to refresh the position. Once I have moved, I had to click this icon here. Otherwise, the system is not taking the new position as the valid one. So I'm going to press here, and now you can see that the middle range has increased to 0.5. You can also rotate if you want the robot, for example, like this, and then click here, and again, is 1.5, has changed. If you approach the robot to the front, then it's 0.8. Well, you can see that this program is taking the values from the laser. It's this laser that is here in the front of the robot, okay? This laser here, just close to the key. Okay, so that's it for now. And let me show you here that we lack time for explaining about C++ classes, but please go and read it and do the exercise and apply this, because the classes are the most important part on C++. They are the core, at the core of C++. You need to understand the classes, how they work. So we have included here a program that is called Robot Commander that will allow you to create a class to send some velocities to the robot so you can move it. And as you can see, let me show you, the program is quite simple. Okay, it's very, very simple. We have simplified this very much. So it's quite simple, but it will allow you to move the robot doing a circle. Okay, so please have a look at that. Then that is all for today. Just wanted to ask you one thing, is that we are creating a course for C++ for robotics. So we are creating this course, as we have created already one for Python for robotics, and it's a free online course. So let me show you this Python, for example. So in this course, the link is there. You can have it on the notebook, so you can check later. Is this course here, and it's a Python course where you are going to learn Python, but in a way that is directly applied to robotics. So it's not learning how a list is, what a dictionary, how to create a program, but specifically applied to a robot. And that course is free. So you can click here and start learning for free. It has several units. You can access all the units. You are going to use two robots, Summit XL and Turtlebot, for learning Python. You are not going to learn ROS with this. This is for learning Python, okay? First, learning Python, but using robots to learn it. So you can apply directly to the robots. Now, we want to create the same course for C++, but I think that we need your help. We need your help in order to understand what you would like to have in this course. For example, there was a question by Kashif that he said, hey, I want to understand how to include my own libraries, my own headers. So that's a very good point that we should show in this course, how to do that. But what else you would like to have in that course? Can you tell me this on the chat? Can you tell me? If you help me on that, then we can create a better course for the community. So we are going to provide this also for free. It's completely for free. No subscription, no limited time or limited hours or whatever. Is going to be for free. And what is interesting is that it's using simulations of robots on the cloud directly to apply this. So anybody can use it. Anybody can learn. So let me know what you would like to have there. And now let me check. Let me disconnect now the sharing. And let me check. Hello, guys. Let me check if there is any question here. If there is any question on the, well, I see many questions. Let's start from the bottom because too many questions. So then let me see. What the advantages? Gerin is asking, what's the advantage of C++ compared to Python? That's a question that I get asked many times. And what I would say is that C++ is a lot more complex, but a lot more complex. I mean, finding errors in C++ code it's a nightmare. That's the disadvantage of C++ in front of Python. Python is very easy, it's clear, it's very few sentences in order to achieve something in robotics. That's very very nice for you, for your feelings, because you see that something is working very quickly. However, then if you need to work with products, with robotics products, usually you are going to need to have C++ because you need to move faster. So C++, because it is compiled, then it can execute a lot faster than Python. Python, it's at the same time that it's executed, is being compiled at the same time, so it goes slower. But Python is all better in order to create prototypes, C++ for commercial products, let's say. So usually, if you go to the industry, you are going to need to learn C++. If you are going to research, universities, research centers, it's better Python. I recommend that. General answer, okay? Then Marcus says, does ROS support other languages than C++ and Python? Yes, a lot of them. The problem is that I don't recommend you to use them unless you are tied to that, because the support is a lot lower, and then it's a lot more difficult to create the nodes. If you have problems, there is fewer people that are going to help you on that. And also many things don't work in other languages. So you will have to implement yourself. But you can mix, okay? So in a ROS system, that's the beauty of ROS, okay? In a ROS system, you can have inside the same robot, you can have a node that is being on Python, another one that is being on C++, another one that is being done on Swift language, for example, or Lua, or other languages that are. Check the webpage of ros.org and you will see all the supported languages. Okay, then Palaf says, thanks, Ricardo, got my answer. Okay, I don't know. Okay, so many questions, but I think that they are linked one to another. So, and then you are talking between you very late today. So guys, I think I'm going to leave it today here. Please, I haven't seen any answer related to what you would like to have in a C++ course for robotics. Please let me know this, or if you're watching the video right now, not live, please put it beneath the comments of the video. That will be very helpful for the whole community, for us also, because it's centering our efforts towards what you like, and also for the community, because we are going to provide to everyone for free. So thank you very much, guys, and I see you the next week. On the next week, we are going to do something very special. We are going to talk about robotics, learning robotics by using ROS. So that's something different. So we are not going to learn about ROS per se, but about robotics. So for example, we are going to work first on obstacle avoidance. And we are going to show how to create an obstacle avoidance algorithm that is very basic in robotics. It's called the BUT algorithm. And then we are going to use this for learning how to avoid any obstacle that the robot is in front. And for that, we are going to use ROS. Okay, so we are going to get one algorithm that is typical in robotics, and we are going to implement it using ROS. That's the challenge for the next week. So thank you very much, everyone, and see you on the next live class next week. Thank you, guys. Okay, yes, finished. Yes. Oh, yeah, my coffee, thank you. Oof, still very, very hot, but what is happening here?